And then later, we've got a space-themed pub quiz to round things off. Before we kick things off, I'd like to take a minute for a quick plug, though. Our main science chat show from the Natural History Museum is called Nature Live, and it goes out on our YouTube and Facebook every Tuesday and Friday. Some of you might have caught a show or two already. We've been nominated for a Time Out Award in the Arts and Entertainment Saviours category, and we're up against some stiff competition, so every vote counts. If you've enjoyed the shows, please do show some love and give us your vote. If you haven't seen Nature Live before, I can very strongly recommend that you check out our recorded shows on the Natural History Museum's YouTube channel. Okay, now that's out of the way, let's get stuck into tonight's conversation. I had provisionally titled this session, Space, because we've got three scientists representing all of our favourite M words, Mars, the Moon, and meteors, although we'll unpack that last term a little bit later. First up, representing the red planet, we have Sarah Matagian, who's a PhD student at the museum. Hey, Sarah. Thanks.
Hi. Yeah, no problem.
So for Team Moon, we also have merit researcher Sarah Russell. Hey, Sarah.
Hello. Hi.
And showing out for the meteors, asteroids, comets, and all manner of other little space rocks, it's PhD student Helena Bates. Hi, Helena.
Hi there.
So first up, let's get a little bit of background on each of these subjects so we know where we're starting from. Let's start closer to home. Let's start with the moon. Sarah, well, we've all seen the moon up in the sky, but what really is it?
Well, yeah, that's right. I mean, one of the big reasons I love talking about the moon is because everybody's seen it. So some people in the world have never seen a mountain or the ocean, but if you can look upwards, then you've seen the moon. And what it is, it's a grey rock about 3,000 kilometers across, about 250,000 miles away from Earth. And it formed when there was a catastrophic impact of a planet-sized body into the early Earth about 4.5 billion years ago. And basically the debris from this collision caused a spray that eventually coalesced to form our moon.
It's amazing to think that the moon, something that we think of as very distant, is actually made up of bits of the Earth. But why don't we see a big chunk taken out of the Earth from the impact?
Well, it was such an energetic impact that it actually melted the Earth almost right down to its core. So it would have been absolutely the worst day in Earth's life, basically. It would have really disrupted everything on the crust and the mantle of the early Earth. And because it was left molten, then it eventually managed to assume its spherical shape.
Well, I guess that puts 2020 into a bit of perspective. At least we don't have a giant planet-sized rock smashing into the Earth. Yeah. Fingers crossed. Let's go a little bit further and let's look at Mars. Sarah, a lot of us have heard of Mars, but let's lay the baseline there.
Okay, so we're like 250 million miles out from Earth here. So Mars is one of the terrestrial planets, one of the rocky inner solar system planets, and it's the next one out from the sun, like after the Earth. So sometimes it's called a sister of Earth, so it's a little bit different. We think they will start off kind of in a similar situation, but Mars is quite a bit smaller. So it's led to a few effects in its life that made it a little bit inhospitable to life like ours, kind of present day. So it doesn't have a magnetic field the way the Earth does, so it's not protected from solar radiation, which means it's really cold, which is why we see kind of those polar caps, which is where most of the water ice is on Mars and under the surface as well, actually.
Well, cold and barren, I don't know, after this heat wave could be a little bit of a blessing.
Yeah, I definitely go.
I mean, if I had the chance, I'd be going there with you. Helena, we mentioned meteors. It's a bit more complex than that, though, isn't it? We've got meteors, comets, asteroids, meteorites. Why don't you unpack some of those terms for us?
So meteors, you might more commonly know as shooting stars. So these are little bits of dust and rock that enter the Earth's atmosphere. And then when they enter the Earth's atmosphere, the friction with all of the air particles causes the outside to burn up, and you get this really bright tail, which is a shooting star, or a meteor is a technical term for it. But it's only one part of a much wider story, because actually meteors, for the most part, come from asteroids. So asteroids, this is an example of an asteroid, are rocky bodies that orbit the sun, and most of them are left over from the beginning of the solar system. So these are things that never grew large enough to make it into planets. Most of them are concentrated in an asteroid belt between Mars and Jupiter. And because there are lots of things, lots of bodies there, they can knock into each other and can knock bits off. And some of those bits that get knocked off can be lucky enough or maybe unlucky enough to fly towards the Earth and then enter the Earth's atmosphere, becoming a meteor. And if it's if it's a kind of large body that enters the Earth's atmosphere, it can survive that really hellish journey and land on the ground, at which point it becomes a meteorite, which is something that we can then hold and study and use to kind of investigate the asteroids that we think they came from.
So meteorites and meteors are, a meteor becomes a meteorite. So they're kind of at different stages in their kind of lifespan.
Exactly. Yeah.
So what about comets?
So comets are kind of their own special little breed of rocky body. We think that they form really far out in the solar system, so out beyond the orbits of Neptune and Pluto, and which means that they have lots of ice on them because it's very cold out there. But they've been knocked for whatever reason and are now traveling in this really bizarre orbit where they come really, really close to the sun and then really, really far away again. And we thought that these things were called dirty snowballs. They were basically just lumps of ice that were coming close to the sun, and then like the material on the surface was kind of burning away, getting the tail that you associate with comets. But actually, we've been to visit them, and they look a little bit more like the asteroids than we really expect. So that line between what's a comet and what's an asteroid is actually not as clear cut as we might kind of have originally understood. So it's a really interesting topic.
Oh, who knew space was complicated?
Yeah.
Now that we've kind of set a baseline of where we're starting from with these topics, let's transport ourselves there. So Helena, if we were standing on an asteroid or a comet, what would it be like? What would we see? What would it feel like?
Well, the big issue with standing on an asteroid or a comet is that they're probably quite small. So I don't know the exact number of asteroids that are above a certain size in the asteroid belt, but most asteroids are between 100 meters and 1 kilometer in size. And things of that sort of size don't have enough gravity for you to kind of stand on. So you would just kind of like fly over it. And if you took like one wrong step, you just go flying off into space. So maybe not quite ideal.
So it'd be less an idea of standing on it and more kind of holding on for dear life.
Clinging on for dear life. Yeah, exactly. So there is one asteroid in the asteroid belt. It's actually no longer an asteroid. It got upgraded to a dwarf planet, and that's called Ceres. And Ceres is the largest thing in the asteroid belt. It's about 900 kilometers in diameter, so still small compared to, for example, the moon. But it's large enough to actually be spherical and to have some gravity. So you would kind of sit on it, and you could, but if you and stand on it and not cling on, but it would be a completely different experience. You'd be able to see the curvature of the body from just like where you were standing. But the cool thing about Ceres is it has cryovolcanoes, which are volcanoes where they spurt out ice rather than lava. So you get to see some cool stuff while you're there.
It's amazing that it's something that we'd kind of recognize as a volcano, but works totally differently, and it's so alien. Exactly. While we're on the subject of flying spacewalks, we have a question from William, one of our viewers, who's asking, on the subject of meteors, how big does a meteor have to be to survive traveling through our atmosphere?
That's a really, really good question. It kind of depends on what the material is made of. But essentially, if you have a body that's about the size of a house or a bus, something like that, it will probably survive in some form when it comes to the atmosphere. But when it does, it breaks up into lots of different little chunks. So it's no real kind of danger. It's not going to cause a crater or anything like that. But that kind of order of magnitude of size is what is the kind of thing we're thinking of.
So what sort of size would something have to be to leave a big crater?
Quite a bit bigger, I think. The general rule of thumb when it comes to craters is if the size of the crater, if you divide it by 10, that's the size of the body that caused it. So you look at some of the craters that we have on Earth, and there are the craters that are about 1 kilometer in diameter. And then you can assume that the body that caused that was about 100 meters in diameter. So things about that kind of size, but that doesn't happen very often. So yeah, nothing to worry about.
Okay, so from Ceres or Ceres, let's go over to Mars. Sarah, if when you go on your spaceship to Mars in your hypothetical dream, what would it be like when you step out of the landing module and you're on the surface of Mars?
So it'd be pretty red. The entire surface of Mars is a fairly nice red color, but it really depends on where you are on Mars, because you could be in a massive canyon that's almost the size of the entire United States from east to west. Or you could be near the tallest volcano in our solar system, Olympus Mons, which is pretty amazing. In between that, you've also got things like lava tubes, which, well, if we land, we're not going to land in them, but that's kind of maybe one of the places that we might use as shelter if we were to stay. That might be quite important. So it depends. You see some of like the solar system's best sites, I think, if you're on Mars.
I think we've got an image as well of a Martian sunset taken by one of the missions that we've sent there, and it's
pretty amazing.
So obviously you'd have to wear a spacesuit, right?
Mm-hmm. Yeah, so there's a few reasons why we'd have to wear a spacesuit. So, like I said, Mars has no atmosphere anymore, or has very, very little atmosphere anymore. So we're not protected from solar radiation and cosmic radiation. So we need some sort of suit to help protect us that. Again, because of the really small amount of atmosphere that it has, we don't have the same pressure that we do on Earth to kind of like keep our bodies together. So we need some sort of like compression system in our EVA suits. And we also need something to supply us with oxygen, because Mars' very, very small atmosphere is mostly CO2, which is fairly poisonous to us. There's a few reasons that we need some kit.
So it's Earth's sister, but it's
they're more like cousins, I think.
Sure.
Yeah.
Okay. Lastly, the moon, Sarah. I mean, I guess it's the only one that people have actually been to, so people can tell us what it's like.
Exactly. So yeah, the Apollo astronauts have actually set foot on the moon, and so their kind of stories and anecdotes tell us an awful lot about what it's like to actually be there. Of course, so the gravity of the moon is much less than that of the Earth, so you bounce around a bit when you're on the surface of the moon. It's covered in this dust, which is lunar soil is called regolith. It's covered in this regolith, which is actually made up of very sharp little bits of dust. And if you breathe those in, it can actually be really bad for you. So it can cause a lot of problems breathing in, which is potentially a problem for astronauts in the future. The astronauts said it smelled like gunpowder. So it kind of smells like it's fireworks night on the moon.
It smells like fireworks, but the air is full of tiny daggers. It sounds super great. One thing the moon is quite famous for is its craters, and we've got a question from YouTube asking what caused those craters.
Yeah, well, this is one of the cool. Well, there's so many cool things about the moon, but it's almost it's something that's very close in space to the Earth, but it's had a very different history to the Earth. And because its geological history is much simpler, and frankly, not a lot has happened on the moon in the last 4 billion years or so, the surface kind of records everything that hits it. And these craters from the moon are records of its impact cratering of bits of asteroids and comets hitting the lunar surface. So that can tell us an awful lot about also what's happened to the Earth, because this cratering also happened on the Earth, but the Earth's very good at kind of resurfacing itself. So we don't have the evidence for that on our own planet.
Are the far side and the near side different?
Yeah. So the far side is super cool. In some ways, the far side is the kind of most mysterious place ever, because it's the one place that we can't see at all using a telescope from Earth. We have to actually go in a spaceship and go and visit it. And it does look different. So if you look up to the near side, you can see it's covered in these dark blotches, which we're very familiar with. And these are called the Mare basalts. They're actually volcanic plains on the surface of the moon. And the far side has very few of these Mare dark splodges on it. So it's one of the mysteries of lunar science, is why the near side and the far side are so different to each other.
And a viewer called Andrew has asked, I think my favorite question so far of the evening: do any moons have moons, and are they called moons?
That's such a good question. I don't know. I bet. I mean, some of the moons of Jupiter are quite substantial in size, and our own moon actually is very sizable as well. So I wouldn't be surprised, but I don't know. Don't know if any of my colleagues know.
Well, or maybe something for Andrew to enroll in a PhD in astronomy to do. Get your applications in now. And we've heard from Helena about cryovolcanoes on Ceres. Is there any kind of like volcanic or tectonic earthquake activity on the moon, or is it just a sort of solid ball?
Yeah, so it was more geologically active when it was younger, in its early days, and that's partly because the rate of impact, so a lot more, the solar system was a much more crazy place several billion years ago. There was a lot more kind of space debris flying around. Now things have calmed down a little bit, and many of these large impacts actually were big enough to produce enough energy that it kind of melted the surface of the moon and caused this volcanism that we now see on the moon. So it does have geology and it does have volcanoes, but we think they're probably, all the volcanoes are extinct. But one of the fairly recent discoveries about the moon is that actually the volcanism has gone on for a lot longer than we thought and longer than we expected. And there's a Chinese mission coming up that will actually visit one of the younger volcanic regions of the moon. So it'll be really interesting to look at how these volcanic regions have evolved over time.
And I think this leads us quite nicely onto the next thing I wanted to discuss, which is, you said that the moon was formed 4.5 billion years ago or so, and that because it doesn't have the kind of geological processes and life processes that Earth has, that it kind of preserves that record of what's happened to it. So what can we learn from the moon about the early stages of how the solar system was formed, or how Earth was formed, or anything like that?
Yeah, well, a lot is the answer. So the Earth's quite an exciting place to live because there's a lot going on all the time. There's volcanoes, there's life, there's oceans, but they all kind of muck about with the surface of the Earth. And so the oldest rocks on the Earth are pretty much have gone away. Whereas on the surface of the moon, many of the rocks on the moon were formed very soon after the moon itself formed. And so it's kind of it tells us about these very early stages of our solar system and what's happened to the Earth as well as to the moon. It's the only place where we can find out what was going on in the Earth 4.5 billion years ago, because we don't have those records on Earth. And it's also an important geological laboratory, right? Because it tells geologists what happens when you have a very pure system of heating rocks and you don't have to worry about the interference of life and water and all those complicating things.
Oh, all those bits of noise.
Yeah.
It's amazing that we have that whole resource. It's like a library and a laboratory and an archive just in the sky.
Yeah.
I'm going to address that same question to Sarah about Mars. Again, it's similar in some ways to Earth, but different in a lot of ways, and it's gone through different processes. What can it teach us about the universe and Earth itself?
So it's fairly similar to the moon in that it has a really well preserved record of what's happened to it, because it's not like regenerating all the time the way the Earth's surface is, with like crustal movement and stuff like that. So we have a start point that was quite similar, we think, to Earth at one point, and we can actually see its kind of endpoint, which could be a potential endpoint for the Earth as well. So we can look back and we can find these rocks and then figure out the processes that happen to them that don't exist on Earth anymore, which is really cool. For me, the cooler part is it's the first step, or the next step, I suppose, that we have to looking at whether or not there's life there, whether or not there's life in our solar system. And regardless of how likely or unlikely that might be, it's our next step in kind of working through that theory, which I think is the most exciting thing.
And we've got a question from a viewer called Emily, who's asking, so since the Earth has a lot of layers, and you have kind of the solid crust and then kind of mantle and more liquid layers, but the inner core is solid because it's being kind of compressed by all the earth around it, right? And Emily's asking, if Mars is smaller, does that mean that its core isn't solid? It hasn't been squished down, it's still molten? Or what do we know about the inside of Mars?
So this is a really good question, and it's a little bit more complicated than just the pressure. So the thing that Mars doesn't have that the Earth has, which has allowed it to keep this kind of molten moving core, is it wasn't big enough to have enough heat to keep it liquid, essentially. And as the core kind of solidified down and didn't have that movement, that's why the magnetic field lessened and lessened, which took away its protection from the sun. So it's not just the pressure at play, it's also the kind of intrinsic heat that the planet had. And because Mars is so much smaller, it had a lot less of it, and it was able to kind of dissipate a lot faster.
Amazing. It's amazing how the more that we know about the kind of the Earth and stuff, we can apply that all throughout our solar system and or beyond, and how that knowledge can then help us understand life on Earth.
Absolutely.
The objects that you're talking about are, I guess they're quite varied in how old they are and how far they've traveled. I mean, what can we learn from them?
Was that to me? Sorry.
Yes, sorry. Yeah. Hello.
Yeah, so I think out of the three bodies or the three things we're talking about today, I think that we can all agree that the asteroids that I look at in particular are the oldest things. These basically formed, they were amongst the very first solids to form in the solar system. So the asteroids that I look at are about, I think they've been dated to 4.567 billion years old. So ever so slightly older than the Earth and Mars and the Moon. So essentially, they're kind of this snapshot of the beginning of the solar system. But there are some asteroids that have kind of survived, obviously, up until now. And when we investigate them, we're looking at a kind of different time period of the solar system. So it's pretty cool.
I guess because comets are constantly coming in and out of the solar system.
Yeah.
They pick stuff up on the way in and out?
Well, so we don't think they do. In fact, they actually lose quite a lot of material when they come close to the sun, because the surface is made of ice. When they come closer to the sun, they basically lose material because that material melts and sublimes. It turns into a gas. So you get this like tail of material flying off. So comets kind of, again, we think these are very primitive, very, very, very old bodies that formed right at the beginning of the solar system before there were kind of things like planets present. And these get to sample like very far outer reaches of the solar system, whereas some asteroids came from kind of closer in as well. So they're basically, asteroids are great because you can pick any time period or location in the solar system, and you'll be able to find one that will tell you some answers about it. It's pretty cool.
And as well as teaching us about the kind of the early stages of the solar system,
mm-hmm.
can they teach us about maybe life? Because I'm aware that there's one hypothesis about kind of the origins of life on Earth that some of it could have arrived from space, something like that. Would you mind elaborating on that?
Yeah, of course. So when the Earth was forming, it actually formed far too close to the sun to have water stable as a liquid. It was too hot, so water basically wasn't able to accrete and wasn't able to become part of the body that eventually became the Earth. So we think that the Earth was actually dry right at the beginning. So then this is obviously not dry now. So then this question comes up, like, where did all the water come from? And one of the theories is that asteroids and comets might have delivered water from the outer solar system to the Earth right in the early stages as the Earth was finishing forming. And one of the really cool things about meteorites and asteroids and comets is when we sample them, when we have a look at them, we can see organic molecules inside them. So we see evidence that there was water present, but we also see evidence of organic material. So these are not life, nothing like that, but the building blocks of life. So things like amino acids and things that build DNA are present in these bodies that are from space. And so this kind of raises the really cool question of if these bodies brought water and if they brought organics to Earth, perhaps they kind of acted as like a seeding mechanism for life, which is really cool because also these bodies were flying around everywhere in the early stages of the solar system. So probably they landed on Mars and probably they landed on Venus as well. So, it makes it sound like the possibility for kind of complex organic material to form is not unlikely. It's really cool.
And I guess it also begs the question, how did those molecules get onto those asteroids and comets in the first place?
Yeah, that's a really, really good question. Creating organic material, creating carbon-based like complex molecules, I think is quite a complex biochemical reaction, maybe, that I'm afraid I don't know how.
Sarah, what about Mars? We hear a lot about, the idea of life on Mars and whether there's water, whether there's microbial life, whether there was life. Let's straighten this out.
Sorry, the audio just went a little bit there. Can you repeat that?
Oh, sorry. I was asking, what do we know about the idea of, or the possibility of life on Mars, present or past or future?
So We have a few pieces to a really big complex puzzle. We've found organic matter on Mars, the Curiosity rover. We don't know from the origin of it yet. So the idea for NASA 2020, which launches this year, and ExoMars 2022, which will launch in 2 years' time, is to try and solidify some more of those questions. It's a really, really complex problem. So life as we know it can't exist on at least the surface of Mars at the moment without water, without shielding from radiation, without oxygen. It's not to say some other life could exist, but it's more likely that we'll find life on Mars under the surface, or there's actually, or at least we think at the poles of Mars, there's a subglacial lake, which is probably very salty, very briny, which actually we have found similar instances on Earth that are quite similar, very cold, but still have a lot of ice, so they don't freeze. Sorry, very cold, still a lot of salt, so they don't freeze, which can have microbial life. So places like that might be a really good location. They're just very difficult to get to. So one of the things ExoMars 2020 is going to do, it's got a 2-meter drill. So it's going to get hopefully more than a meter and a half down into the surface, get past that radiation barrier into the shielded part of kind of Mars's lower surface, and see if there's any fossilized life, any indications of life that ever passed, or I mean the hope, the dream would be any living life, but whether or not that's feasible is a whole other thing.
That would really be an absolutely mind-blowing discovery, wouldn't it? That would change pretty much everything we know about our local universe.
Yeah.
We've always thought that we were the only ones. Yeah.
Yeah.
We've got a question from a viewer called Daniel, who's asking if you, and I'll put this to all three of you actually, if you were offered the chance to go on a 3-year flight to Mars, would you rather go? Would you go, and would you rather go on your own, or would you take others with you?
I would definitely want to take other people with me. So it's a long time to be on your own, and you're in very, very small quarters. What some of the space agencies are actually doing right now, which is really cool, is they're looking at essentially robotic companions to facilitate like feelings of having like a human companion without actually having one. So it is something that's really important, that your well-being and your happiness while you're on these like very long, very arduous journeys. So I think like robots are cute, and I'm sure they'd be great friends, but it can't really substitute for another person.
Well, we've all seen those sci-fi films where there's a kind of robotic companion, and then
they almost always
turns evil and kills everyone.
Yeah.
There was there's a robot called Simon, who's like a floating orb that is being developed for use on the International Space Station. Right?
Yeah.
They did a kind of public trial of the conversation feature, and it got a bit grumpy. It had a bit of an argument. Had a bit of a sulk.
I mean, AI is only as perfect as the people who code them, and humans are imperfect too. So yeah, they're limited by what we can teach them.
I think that's important to remember. The discussion,
absolutely.
I often forget that actually they're made by people.
Yeah.
And all those biases and imperfections go in there.
Absolutely, yeah.
Sarah, if you had to go on a long space mission, would you take a robot? Would you go on your own? Would you take people?
Personally, yeah, I would go, and yeah, I think you'd have to have other people with you, otherwise anybody would go really crazy, right? But yeah.
I mean, lockdown has already done enough damage to our mental health. You don't need to be stuck in a tin can for several years at a time.
Yeah. Yeah.
Helena, are you going to give a dissenting opinion?
I mean, I would only go if I was guaranteed to come back. I'm one of these people that never really likes the idea of going to Mars or the moon or something with like kind of, to establish a colony and not to come back. I don't really think that I would like that. I also, maybe the sort of close, playing devil's advocate, the close living quarters would mean that maybe you don't want other people there because it's a very intense environment. That being said, I would definitely take other people because, of course, like.
And I agree with your point about maybe being a bit reticent to be the first to go there to colonize, because whenever a new phone comes out, you don't want to be the first one to get it. It's all buggy. If you're going to be the first one to set up a colony or a living space on a new planet, it's going to be tough. Maybe wait for the others to do the hard work and then.
Yeah, exactly. I would like a guarantee that I'm going to come back.
Yeah, you know, once they've set up, you know, the cafe and the social stuff.
I
So
think it's quite unlikely that we'll ever actually send manned missions that have no option to come back. I think I'm not sure if any space agency would actually kind of assent to that, but I mean, I would still go, I'm not gonna lie, but I know a lot of people wouldn't.
And don't they have like training programs or experimental kind of programs where they simulate living in a kind of enclosed Mars habitat by putting people in a shed in the desert?
Essentially, yeah. There's actually the Mars Desert Research Station. I think it's in Utah, in America, where essentially you've got like a little hab unit. You've got your like spacing out into the Utah desert and kind of do some experiments, things like that, and it's to get you some kind of real face time with what it would be like to live with 5 people in a tiny little hab unit and only be able to go outside in a really bulky, uncomfortable spacesuit and barely be able to move. So
yeah, I guess that this the trade-off you've got to make with this grand. On the subject of going and kind of exploring and establishing kind of human settlements places, I guess we've got to be quite careful about kind of the way we talk about words like colonization and stuff like that, because it might seem like semantics, but actually the way that we frame things, the words that we use can affect how we think about it. And if we're going to colonize Mars, then that implies that we're going to go and own it, and we're going to start drawing lines in the sand. What sort of terminology do you think would be more helpful to talk about going into space and being there?
I would always bring it back to exploration and like development of settlement, maybe. So there's like colonization is a really violent history. Like we don't need that like in the future. We don't want that in our reality anymore. So yeah, there's also like terraforming has some kind of negative connotations, and you can talk about like geoengineering a planet. So there's a lot of kind of intricacies to like the way that we should discuss things and things we should think about when we're discussing them too.
Helena, you were going to say something, weren't you?
I just said use maybe the word base or something.
Sure. Well, I mean, on the subject of bases,
crewed missions. But
yes, crewed rather than manned.
Crewed missions.
Yeah. 21st century
yeah,
people.
We do not need an entire spaceship full of men going all in one direction. Yeah, I think you're right. Any kind of space exploration in the future has to embrace and utilize like all the richness of differences in people from all over the world. That's why it's great to see international collaborations like the International Space Station and stuff like that. But on the subject of settling missions or creating bases, I guess the nearest and most likely one, Sarah, is the moon.
Absolutely, yeah. And I think all the major space agencies have got plans to go back to the moon. So NASA are hoping to get humans, including the first woman, back to the moon in 2024. And the European Space Agency are also very actively planning lunar missions at the moment as well. So it's all happening on the moon, and very much the plan is to get people back on the moon as well.
So other than having a base on the moon full of people being really cool, what's the point?
What's the point? There's so much point.
Sell it to us, Sarah.
Right. So I mean, there's a lot that having people on the moon can offer. So firstly, we've talked a little bit about the science of the moon, that the science is this amazing archive of our entire solar system history. So there's a lot of work that we can do to understand our solar system and also the galaxy as a whole by working on the moon. So there's the basic science. There's also the fact that the moon's actually a really good place to have a spaceport, because it's really hard to explore the solar system, and the hardest bit is actually blasting a rocket off the surface of the Earth. So if we could start having rockets blasted off from the moon instead, where there's much less gravity, that's going to be a lot easier. So I'd like to see a spaceport there. Then also, we have to think about the ethics of this, but potentially there are resources on the moon that we could use on Earth as well. So there's kind of possibly economic reasons to go to the moon as well.
But then I guess, going back to our earlier point about kind of the colonization and stuff like that, if we start extracting resources from the moon or other space bodies, we've got to decide, who gets to extract them and what those get for and how much do we take? Are we going to hollow out the entire moon? In fact, what would happen if we hollowed out the moon?
I think that would be a pretty massive mining project. Frankly, not sure that's totally
in a hypothetical, because we actually
in a hypothetical. If we
had a question from a viewer we had a question from a viewer who's asked, what if the moon just disappeared?
If it just disappeared, right?
I was finessing it a bit. Imagine if it was just a hollow shell, or if it disappeared.
If it disappeared, well, firstly, if it completely disappeared, it would be very sad. To not have it anymore. So I think
you need to find a new job.
Yeah. I think culturally, though, it would be a disaster. Firstly, secondly, it would. The moon has a bit of a role in stabilizing the wobble of the Earth. So it means that it makes our climates more stable than they would otherwise be. So there'd be more changes to our climate over a short range period of time. And then, of course, the moon causes the tides caused by the gravitational pull of the moon, and there's a load of biological activity in tidal regions, so this huge biodiversity would be lost. Then the moon is used by many animals for various things, so it's a source of light primarily.
For synchronizing their breeding and stuff.
Yeah, exactly. Yeah,
corals and turtles and stuff. Yeah, they use them to synchronize that.
Exactly. So I think it would cause a huge biodiversity loss as well.
So So in answer to Andrew, a lot of bad things would happen.
Yeah.
So looping back to the idea of living out there or extracting things. Well, I'm going to ask this to all of you, but I'll start with Helena. How do you think the rules would work out there? Would we have to rewrite new rules, or could we transpose some of Earth's laws and rules to go out there? Because if we're, for example, settling on Keres or mining asteroids or something, we're going to have some ground rules.
Yeah, I think it's a really interesting one. There's actually like a whole topic of study that's been dedicated to looking at, what the laws might be in space. There's a whole branch of space law and things like that. So I think I'm sure it would basically have to be completely rewritten. I don't think many rules on Earth would be applicable to kind of some of the issues that you have in space. So I think it's almost an opportunity to just kind of like try and make it a collaborative thing, and as humanity's effort to do this, that, and the other, and rather than this person owns that thing and this person owns that owns that thing. It's really interesting, but I think it is something that's actively being studied, because I think it's going to become more and more of an issue when we start going and establishing bases and places, and we start traveling further out in the solar system as well. So hopefully some very clever minds will come up with some very clever ideas for us.
Yeah, I guess you're right. It's something we've got to make sure we get right before we go.
Yeah.
Turn up and be like, oh, what are the rules?
Exactly. I think there's a rule: no country is allowed to own part of the moon. So these things people have thought about them a little bit. I mean, we haven't much, because not much exploration has happened yet in the grand scheme of things. So
I guess an example closer to home might be Antarctica. Oh, sorry, Sarah, you were going to say something.
Yeah, no, I was going to make that point. So I think it's important to kind of learn lessons from what we've done to the Earth, and there's some kind of bad examples of us messing things up on the Earth, but there's some good examples as well. So one example is the Antarctic Treaty, which protects the continent of Antarctica, and then also looking at the deep sea resources as well is also something that's been covered by international treaties as well. So I think we can use those sort of examples as templates for how we explore space as well.
Okay, so if we've got our space rules and we've got our kind of service station on the moon, Sarah, what about a base on Mars? How feasible is that? How might we go about it? What about that?
Feasible currently right now, that's pretty low, but in maybe a few decades, it's a real tangible possibility. There's a lot of things that we need to survive to live as humans, and Mars doesn't have kind of any of them really. So we have to either we have to weigh up whether or not we can take those things with us, or if it's things we're going to have to find there. It's called in situ resource utilization, which actually there's a real argument for a lot of things we could maybe do on Mars. Mars's atmosphere is pretty humid, so we could essentially use a dehumidifier, try and extract water out of the air. If we settle in, say, lava tubes, or if we use the Martian regolith as part of our building materials, we could get something that will shield us adequately from radiation.
So the regolith is this dust that's all over the surface?
Yes, sorry. It's the kind of like dusty surface of Mars. So you're basically using Mars itself to protect you. So you can either go underground and it's already built this for you in lava tubes, which are really cool. They're really massive on Mars because the gravity is so much lower. Or you could build a hab unit on the kind of surface.
I absolutely love the idea of these lava tubes.
Yeah, they're really cool.
I would want to live in a lava tube just to say I lived in a lava tube.
Yeah, they actually, so the way you can tell where lava tubes are on the surface of Mars, you get these kind of like pit-like craters where essentially they've collapsed in a bit. You've got 3 skylights already in, like, it's amazing.
And I guess you'd be, because you're underground, you'd be a bit shielded from the radiation and maybe the dust storms. Because that's something we haven't mentioned, actually. Mars has some dust storms.
Yeah, so contrary to the Martian movie, they're not quite as powerful as that. I mean, it seems they're very, very fast because the atmosphere is so thin, they can't do a whole lot of damage. But sometimes most of the planet can be covered in these dust storms. It's quite incredible. That's actually maybe another, like, when you're sightseeing on Mars. Yeah, actually, this is a great image. So on the left, that's standard image of Mars. On the right, basically that entire hemisphere has been obscured because of the dust in the atmosphere being stirred up by the winds, which is pretty amazing. Like, probably not great for, I mean, your solar-powered robots or anything like that, but it's pretty amazing to see.
I guess you'd need a wind turbine as well.
Yeah, probably. Well, so because the atmosphere is so thin, it actually wouldn't help very much to kind of utilize wind energy. If we were going to try and do renewable energy on Earth, on Mars, it's probably going to have to be solar radiation.
Okay, so now that we've gone through kind of some of the more kind of realistic and kind of potential future scenarios of how we might go about interacting with all 3 of these places, let's go down some of the kind of weirder corridors. What are some of the most interesting or the things that have made you really that's really sparked a bit of kind of curiosity in you about each of these things? I'll start with you, Sarah.
Me? Okay, so...
Yeah, so what's the weirdest thing about the moon? What's your favorite weird fact?
There's so many weird facts about the moon. I think the why the far side's different from the near side is weird. I think Sarah reminded me. So the moon's got lava tubes as well. So that's a kind of slightly weird thing that we've discovered fairly recently about the moon. Also a good place for a lunar base. And then, yeah, it's a great thing about the moon is that it sort of inspires everyone. And there's always like some funny stories about the moon. So I know this week, for example, it was, I don't know if you saw that NASA's launched a competition for people to design a lunar loo so that astronauts can use a loo when they're on the moon. So
I mean, it's an unavoidable part of life. And if it goes wrong, it goes very wrong.
Yes, and there are some kind of pretty bad horror stories about the Apollo astronauts and toilets.
Oh yeah, I remember
I'm not going to go there. But.
I remember listening to a transcript of one conversation from one of the Apollo missions, and they're working away on something, and then one of them says, "Oh, whose is that?" Mine was firmer the last week. It's all because a piece of feces has got loose and it's just kind of dinged through the capsule. So, we've all had bad days at work, but that's pretty bad.
Yeah, that's pretty bad.
What about you, Helena?
What's the weirdest or coolest thing? There are a couple of things actually that kind of surprised me about meteorites. When I remember the first time I was kind of handling a very a large piece, and when a large piece, I mean kind of like that sort of size piece of meteorite. The type of meteorites I look at, because they've got loads of organics and metal in them, they smell really strongly of like soil and like a bit like coins. Like it's a really weird thing to kind of smell. There's really like, I don't know, it's just really kind of bizarre that this thing from space smells like soil. I always thought that was kind of weird.
And smell is not really one of the senses that you think about stuff from space.
No, I mean there have been like a bunch of people have done kind of like what does this thing smell like in space, and they always stink. It's the worst thing, because they're always heavily like ammoniated or very sulfur rich, and it's just like, why do that? But the meteorites I look at, the smell, it smells almost like, like rain on soil kind of thing. It's kind of nice. I kind of am used to it now. It's quite a nice thing to smell. But the other really cool thing about meteorites is that before planets, before anything, the very, very first solids that formed were these little kind of fluffy dust bunny like things. And meteorites, actually, some of the meteorites that are from that period of time have incorporated some of those first solids that ever formed. And you actually can touch them. This is what's really cool. You get to touch the first solids that ever formed in the solar system, which I think is like...
That is very, very cool.
Yeah.
So I've been struck dumb by a little pang of jealousy. When the museum's open, can I come
to the
and
collection?
have a
Yeah,
little
come to the
look?
collection. Yes, yeah, we'll let you come and have a look.
So anyone out there, if you want to touch the beginning of the universe, come to the Natural History Museum.
Yeah.
Come and work with us. Sarah, what about Mars? I mean, all of these places have a lot of weird, cool things about them.
So I think it kind of like ties into the latitudes and stuff, but I think the coolest thing is that there's so much untapped potential in the places that we could search on Mars for life. And it's kind of one of the arguments for sending people. Like our robots so far have done an amazing job, and the ones that we're sending now are going to do incredible things. But there's no substitute for actually being able to go and investigate and explore, like as a person with boots on the ground. So like those latitudes, if life did exist, it's more likely to be there than on the surface, even 2 meters down, or like those subglacial lakes and things. We have no idea how much we don't know, and I just think that's really awesome.
And I think we've got an image of a selfie taken by, was it the Curiosity rover? NASA, one of NASA's Mars rovers. How long do you think it'll be before the first human selfie on Mars?
So I think probably day one of boots on Mars, the first selfie on Mars. But when that actually happens, I think maybe a few decades. It's really hard to put a kind of pinpoint on it. So I think the US's current goal is back on the moon by 2024, which is super ambitious. And if they can kind of continue with that trajectory, a few decades, and I'm hoping a few decades, because that means I can still go. But maybe that's me. That's just wishful thinking.
So I think it's about time to start wrapping up this first part. I'm going to maybe do a quick round of all three of you with some closing thoughts of if you could give some really solid advice or make some rules for the people who will be like going to space or running these programs or developing the plans for going in and living in space. What if you could make one rule or make one piece of advice, what would it be? And we'll start off with Sarah.
So I guess my piece of advice is a very museum-y piece of advice, but it is always kind of remember that space exploration is for everyone, and you should always have public engagement and science communication at the forefront of whatever you do. Always explain what you're doing, tell kids about what you're doing, and I think that's the most important thing that we can all do, and collect lots of rocks as well. That's also a very museum-y thing to say.
Maybe they should bring a science communicator.
Yeah.
I'm available. Just Isa, call me. What about Helena?
So the advice I would give to people who are kind of beginning, the companies and the organizations that are beginning to think about space travel and going out there and exploring is, much like Sarah said, it is for everyone, but also my little piece of advice, listen to the scientists and the engineers as well. They tend to have, the best interests at heart, and give good advice. So listen to them as well.
Yeah, because so often
that's a very sciencey thing to say, right?
Oh no, I totally agree, because so often in these situations, you get either kind of national interests or commercial interests getting in the way, and you end up
it's a risky thing to do, right? It's like space travel is risky, and you have to make sure that you're doing it properly and safely. And I think the best way to do that is to listen to the people who know the most about it.
You guys.
Yeah, keep me employed.
Sarah, what about you?
So it's it's kind of in the same vein, but it's just thinking about the kind of the ethics of what we're doing and making sure that we're looking at everything through the right lens. Space is for absolutely everybody, and that should be kept in mind as we go forward. The achievements that we get in space are everybody's achievements, the whole human race, and I just think that's a really important kind of aspect that has to be kept in front. This exploration is for the benefit of all humanity, and that's really important.
Yeah, because as Sarah said earlier, we've made a bunch of mistakes already on Earth. What the important thing is to do is for us to learn from those and try and be better as we go forward.
Yeah,
we don't want to go out there and trash everywhere else, just like we've trashed here. Thank you so much. I know that's a bit of a dark ending for the show, but thank you so much for joining us. I hope you guys have enjoyed it as much as I have.
Positive.
Yeah, it's positive.
We're going to go forth and be better than we are. I guess that's the vision Star Trek had. But thank you guys so much. And I've really enjoyed myself. I've learned a lot. I always do when I speak to you guys. Yeah, have a lovely rest of your evening, guys.
Yeah, you too.
Thank you.
Enjoy.
Thank you for having us.
Thank you as well at home for joining us for that first half of Lakes Online from the Natural History Museum. We're going to take a short break now to get a glass of water and get ready for the next part of the evening, which is going to be the quiz. So it's going to be a pub quiz style little game. So get a pen and paper, get a team together, put on your spacesuits, and I'll see you in a few minutes. Thank you so much. Hello and welcome back to Lates Online from the Natural History Museum. I hope you enjoyed that panel discussion as much as I did, but now it's time for our quiz. And to help me, I've got my co-quiz master, my friend and colleague, Alison. Hey, Alison.
Hey, Khalil, how are you doing?
I mean, I had a load of fun and I've learned so much. Now it's time to have a bit more fun and get, we've got some kind of silly stuff at the end, which is going to be really fun. But lay us out the ground rules of this quiz and introduce us.
Absolutely, absolutely. I'll be mum. I'll lay out the rules. Now, I hope everyone's got their pen and paper at the ready. That is all you need to take part in this quiz. There's going to be 3 rounds. Our first round has lots of questions about space travel. Our second round is about the solar system. And if you watched the panel discussion earlier, you'll have a bit of an advantage with this round. And then our final round is my favorite. It's the science fiction round. So,
I'm looking forward to that one already.
I know. We've got some brilliant questions at the end. Now, you get 1 point per correct answer, although there are some bonus points available in the final round. So there's a total of 26 points up for grabs. Do let us know your quiz name in the comments. We would love to hear if you've got particularly space-themed quiz name. That would be brilliant.
There's always time for a good pun.
Absolutely, space puns, definitely. But we please ask that you don't post your answers during the quiz. We're going to go through all of the questions so everyone can play along. Don't post your answers in the comments. Save it until the end when we'll run through all of the answers for you. And the questions will be up on the screen, so you don't need to remember them. So yeah, you can read them off the screen. I think that's it. Have I forgotten anything else?
I don't think so. I think let's go get started. So, round 1, space travel. So for our first question, space travel, it might get more accessible in the future, but for now it's still a quite difficult and dangerous job. And this means that astronauts have to pass some pretty rigorous selection and training requirements. Which of these is not a requirement to become a NASA astronaut? Which one is not a requirement to become a NASA astronaut? So, a master's degree in a STEM subject, so that's a science, technology, engineering, or maths related subject, US citizenship, military experience, or a physical performance test. So write down the one that you think is not required to become a NASA astronaut.
That's quite tricky, I think. Did you ever want to be an astronaut when you were younger, Khalil?
Definitely. I mean, I think we've all thought about it at some point.
Oh, definitely.
And I think it fell out of favor in my mind when I got super obsessed with biology. But now all this talk of space and Mars and moon and stuff, I don't know. Yeah, I think I could be up for it. I mean, they need science presenters on the moon.
Could be one day. So let's have our second question. Now, besides rockets that we use today to get into space, people have come up with some very inventive alternative ideas for getting into orbit. But which of these has not seriously been considered as a way to get people or objects into space? A really big gun, a really big ladder, a really big lift or elevator, and a really big magnet. Impossible though it seems, only one of those has not been seriously considered as a way to get people or objects into space. So which could it be?
I can see big problems with all of them. I mean, I'm not. I'd be up for any of them, really.
Not so much.
The lift sounds a bit comfier than the rest, but
maybe. I'm quite intrigued by the big magnet.
So moving on to question 3. So humans have sent animals into space even before they sent humans up there. And sometimes these are for scientific experiment, or they're always for scientific experiments, but sometimes it's to see whether they will survive, especially in the early ones. And now they're more studying the effects of low gravity and radiation on these animals. Some of the earlier ones were a little bit dodgy in terms of their animal welfare, but nowadays we're a lot stricter, and all these experiments have to be very carefully vetted, and the animal welfare is a top priority. But the question is, which of these animals has not been launched into space yet? I say yet because you never know. Tomorrow they could be sending any of these. But spiders, mice, tortoises, goldfish, jellyfish, or snakes. I mean, I'm not sure I'd want to share a spaceship with many of these. I mean, a tortoise would be pretty cool to hang out with. They're quite chill.
Yeah. Spider would be interesting.
Yeah, yeah. You wouldn't want to be putting on your helmet and just see something crawling down.
Ooh.
That's
That
a
would
horror
be
film waiting to be
exciting.
written.
Definitely. Okay, let's have our next question. So this is a moon-related one. So in January last year, China's Chang'e 4 spacecraft made a historic landing on the far side of the moon. They were the first nation to do this. But this mission achieved another first. What was it? We did something very special. What historic thing did they achieve on the moon last year?
I mean, getting to the far side of the moon is a pretty big deal.
That was impressive enough, yeah.
But not content with that, they did something extra.
Oh no, they did something even cooler.
I mean, if you're going that far, you might as well do something.
True, true.
So that brings us to the end of round one, I think.
I think so.
To round two. Crazy that follows round one, but we're going with it. First question in round two is, so we were talking earlier about the different landscapes in different areas and bodies of the solar system, but where is the biggest volcano in the solar system? That's it. Where is the biggest volcano in the solar system?
Interesting. There are quite a few out there, aren't there?
Yeah, some that spew ice, some that spew lava, some that are extinct, some that are active. There's all sorts of options.
I think people are going to get this one. I hope they are.
Well, if they were paying attention in the panel.
They ought to. They really ought to. Right. So let's have our second question for round two. Now, there are many massive canyons here on Earth. The Grand Canyon that we see here is one, a very memorable example, but there are also these features elsewhere in the solar system. So where is the biggest canyon in the solar system?
So we've gone up for volcanoes, down for canyons. They're all big.
Absolutely. Lots of interesting geology out there in the solar system.
Okay, so if you've got your answers down for that, give you a little time to confer with your space crew. Let's go to question 3. What is the hottest planet in the solar system? So there are 8 planets in our solar system. Unfortunately, Pluto got downgraded a few years ago. Rest in peace, Pluto. It's still there, but it just doesn't count. So 8 planets in our solar system. Which is the hottest? So I'll give you some time to get your answers down.
Trickier than it seems, I think. Some people might get this one wrong.
Yeah, because there are big ones, small ones,
yeah,
close ones, different types of atmosphere.
Right. Our next question, we actually have it's a meteor related question, but it's a picture round. So we're going to show you 3 pictures of 3 different objects, and we want you to guess, are they meteorites or meteorons? So let's have a look at these 3 pictures.
So by meteorong, we mean, is it a meteorite, just a rock?
Exactly. Is it a meteorite?
A space rock or just a rock?
So you get 1 point for each of them that you get right. So is it a meteorite or is it not a meteorite?
All right, maybe let's give them some time to confer among themselves, because these are some very different looking shapes. We've got a real rocky, spotty one on the left.
Yeah.
One that looks kind of like a burnt chocolate muffin in the middle.
Yeah, it does a little bit, doesn't it? It does look quite burnt.
I mean, it still looks a bit appetizing though. And then number three's got that weird kind of figure of 8 shape. It's really smooth. So think about
really strange.
what could have caused all these things, and whether that happened here or in space or what.
Exactly. It looks quite melted.
Enough time?
Doesn't it? I think so. I
think maybe if you left number 1 on a windowsill today, it would probably turn into number 3.
Definitely. I think I've turned into number 3.
Yeah, we've all been there today. So I think we can move on to the next question now. Question number 5. So up till today, only 2 human-made spacecraft have traveled far enough away to actually have left our solar system and gone out into deep interstellar space. Interstellar meaning between stars. What are the names of these spacecraft? So we've got 2 spacecraft. What are the names of these spacecraft that have traveled beyond our solar system? Because I mean, there are loads and loads and loads of things that we've put out there. There are ones that we've sent to different planets, and there are ones that we've sent just kind of going off in a direction.
Yeah, this is a really cool question. I was just, I love the concept that we've got objects out into interstellar space.
And you know, imagine being, you know, an alien civilization living in another solar system, really, really far away. Those probes are going to take ages to even get there. So, you know, maybe in like millions of years, they'll just be minding their own business, and one of our spacecraft will just kind of land, and that to them that'd be an alien spaceship. Who
knows? Who knows? Right, I think we're on to our final question for our solar system round. This one is a slightly tricky one. We've got a tricky astronomical term for you. We want a definition. What is syzygy? And I hope I'm pronouncing that correctly.
That is one of my favorite words. Half of it is Y. That's an excellent Scrabble score.
It really is. And I had no idea what this was when I first saw this question.
It's probably a good band name as well.
Definitely a good band name.
Yeah, I'm gonna start up like a prog electronica band or something called Zizzy. Okay, I think we've given them enough time to not Google it, but look it up.
Absolutely.
To kind of imagine what it could be. So I think that takes us to the end of round 2 as well. Right, here we go. We've gone through the serious stuff, and now we're into the realm of science fiction. Obviously, science fiction is fiction, but a lot of the time, certain types of science fiction draw quite heavily on actual space science. Obviously, some draw slightly less heavily. You know, if we're talking about giant goo monsters or stuff like that, not so much. But stuff like The Expanse and you know, quite kind of what we call hard science fiction is quite heavily inspired by a lot of space science. But our first question is about a real-life astronaut. So Mae Jemison, she's an American engineer, medical doctor, and astronaut, and she was the first Black woman to go to space. And after coming back from her first mission, she got a chance to appear in her favorite sci-fi TV show. And our question for you is, what was that show? Imagine, you know, you're an engineer, or a medical doctor, and then you're an astronaut, and then you go to space, and then you're like, what else can I do? I'm gonna come back and star in an episode of my favorite TV show.
It's not a bad life, is it?
Yeah, she's racking off that bucket list.
Definitely. This is a great question, and I think you could guess the answer. Hopefully fairly easily. Even if you're not sure, I think you could have a good guess.
That's the best part of a quiz. I mean, just no idea. Long shot.
Yeah. Yeah. Right.
Okay,
Let's have question 2. Now, we've got another astronomical term for you to define this time. And this particular term was used famously incorrectly in a particular movie franchise. So the question...
Not naming any names.
Not naming any names. What is a parsec?
So, I don't know. It's like something can do the Millennium Falcon can do the Kessel Run in a certain number of parsecs.
Apparently.
I don't know. I haven't seen Solo, so the original quote is from the first Star Wars film when they're meeting in that cantina.
Yeah.
I hear that it gets explained a little bit better in the Solo film, but I didn't get that far down the spin-offs. I still need to catch up on Mandalorian, actually. So,
me too, actually.
Work out the answer, guys. Now we're coming to my favorite bit of the quiz. I mean, I hope you guys enjoyed this as much as we enjoyed putting it together. So me, Alison, Sarah, and Helena have each drawn some amazing masterpieces of fine art to represent our favorite science fiction TV shows and films. So for 1 point each, we'd like you to guess which film or TV show each of these pictures represents. And for a bonus point, guess which one of us drew it. So, starting us off, what is this? So the artist here has obviously been trying to conjure the raw emotion at the heart of this narrative. They've had minimal use of color and incomplete figures, but I think the naive style really brings out the purity of the piece.
The facial expressions are absolutely wonderful.
The one in the middle doesn't really be fussed. It's like, what is going on?
Whoever drew it has just captured the moment. It's absolutely wonderful.
Okay, let's move on to the next one. So this one, excellent use of perspective and a slightly broader palette than our first entry. This one even includes some dialogue. And if you guys are having trouble reading it, Alison, what does it say?
I need to take my glasses off. It's a bit too small. It ain't over till the fat lady sings.
So you got a little bit of a clue there in the quote. Yeah, I think it's another masterpiece, really.
It really is. We're a talented bunch, aren't we?
We're wasted on this. Okay, going to our next image. So here again, we have a relatively limited color palette, but that really draws out the use of line to denote the forms inherent in the narrative of this film. We've got human figures and buildings, which is a first so far in this exhibition.
Is that a building? I'm not quite sure.
It's a cake. It's a.
Could be anything.
It looks a bit like a Battenberg.
I'm so proud of us.
I mean, if this science communication thing doesn't work out, we could always go and become artists.
Sure.
Okay, let's move on to our fourth image. So this has taken a much more minimalist approach, line only, no shading, really leaving a lot to the viewer's imagination to draw out the majesty of this piece. And also, again, just like in our first piece, great use of facial expressions, really taking us on an emotional journey as we go through this.
It is wonderful. Nice detail on the dressing gown and the towel as well.
Oh yeah. The belt really sets it off. Okay, and going into our fifth image in this category. This is the last one. Okay. So obviously, less talented cheating than the rest. This is a very basic piece. I think.
Yeah.
I mean, what is that even? I can't even tell what it is.
No idea.
Okay, so I'm going to give you guys a chance to try and dissect this, whatever this is. The thing is, the artist who created this thing didn't feel like they were properly expressing themselves in only one image. So we decided to create what we call the Alan Rickman Memorial Bonus Round. And so we have a sixth image, which I think you'll be able to tell is the same shoddy workmanship as our fifth image, but it's a different theme. Let's have a look.
Oh yeah, it's not great, is it?
I mean, I want to cuss it out, but I can't insult anything with Alan Rickman in it.
True.
He's a true legend and a blessing to us all.
And
Rest
again,
in peace, Alan.
Very helpful bit of dialogue there as well.
Yeah, so I think it's great that we're having such a varied approach to the challenge that these artists have been presented with. Okay, so do you think we've given them enough time to work through this?
I think so.
Okay, should we roll back through and do the answers?
Let's roll back and let's have a look at some answers.
Okay, so question 1. So we're asking which of these is not a requirement to become a NASA astronaut? And the answer is military experience. So you do get some astronauts who've been like Air Force pilots or Navy pilots, but actually it's not required. And some of these requirements can also be met in other ways. So the master's degree can be replaced by a medical degree, 2 years of work towards a PhD, or being a certified test pilot. So all really easy things, really. Like,
Yeah.
why we aren't all astronauts.
Oh, I'll do that tomorrow.
Yeah, it's on the to-do list.
Yeah, definitely. So well done if you got that one correct. Let's have our second question. So we asked which of these interesting methods of getting into space had not seriously been considered. A really big gun, a really big ladder, a really big lift, or a really big magnet. So let's have our answer.
I mean,
Big ladder.
they all seem really impractical. That was a tough question.
I know it was a really tough question, but yeah, I think the ladder just about inches it, doesn't it? It's amazing to think, but in the 1960s, the US and Canada built a giant gun, apparently in the Bahamas, as part of an experiment into alternative launch methods. The idea obviously didn't get very far, but you still see the abandoned cannon at a site in the Bahamas. And the possibility of a giant space elevator and a magnetic launcher are apparently still being investigated to this day.
I mean, with the advances in material science and new building techniques, maybe we could get like a lift. I don't know. I wouldn't want to be the first one to ride it, but it'd be
No.
a darn sight safer than that rusty old giant cannon. If you ever needed another reason to visit the Bahamas, giants. So, on to question number 3. Which of these poor animals has not traveled to space yet? And the answer is snakes. Contrary to what Rick and Morty might tell you, snakes have never been sent into space. Maybe Snakes in Space could be a sequel to Snakes on a Plane?
I would watch that.
Spacesuit swearing at snakes.
I would definitely watch that.
It writes itself, really.
It really does. It really does. And it's amazing to think the menagerie of animals that have been up to space.
How would you take a jellyfish into space? I mean, obviously in a tank of water, but like, why?
Poor jellyfish. I wonder how it coped with microgravity. I'm assuming that's the reason that a lot of these animals get taken up is experiments into the impact of gravity.
Of all the animals to be affected by microgravity, I guess jellyfish, what they normally do is kind of drift around. So in microgravity, drift even driftier.
So well done if you got that one correct. Let's move on to question 4. We got the answer already. The Chang'e 4 China spacecraft managed to grow plants on the moon. So not only was it the first to land on the far side of the moon, but they also were the first to grow plants on the moon, which is pretty amazing. The mission included a lunar biosphere experiment, which contained plant seeds, including, I think it was cotton, oilseed, rape, and potato. But there were also fruit fly eggs and yeast. And the idea was they'd make up a mini ecosystem, so the plants could produce oxygen and food for the flies, and the yeast could process the flies' waste, and the dead plants could also provide another food source. But it was the cotton seeds, apparently, that germinated first. Although, sadly, they were later killed when the temperature fell to minus 170 degrees at night time. The lunar night fell.
And the lunar night lasts like 2 weeks or something, right?
Yeah, absolutely.
And I assume this must have been in like a sealed pod.
Yes. Yes.
Pretty. I mean, it'd be hard to grow things in no atmosphere, but also quite irresponsible to go around just chucking biological material all over the moon.
Absolutely. But quite an achievement.
Very impressive. Okay, so going into round 2, question 1, where is the biggest volcano in the solar system? Well, if you were listening to Sarah when she was talking about Mars, you would know that, I just said it, Mars is the home to Olympus Mons, which is named after Mount Olympus, which is where the ancient Greeks believed that their gods lived. So a lot of the planets in our solar system are named after Roman names for Greek gods. Like Mars was the god of war, Venus was the god of love, goddess of love. But yeah, Mars has Mount Olympus on it.
This volcano is incredible, isn't it? It's absolutely huge.
I mean, it's like, yeah, you think of a huge mountain on Earth, and it doesn't even come close to Olympus Mons.
Now, our second question was, what's the biggest canyon in the solar system? Now, again, if you were watching the talk, this might, I think this was mentioned, was it Khalil, this particular canyon? But it is on Mars, and it's called Valles Marineris.
So Mars is home to both the biggest volcano and the biggest canyon. And for such a, it's a relatively small planet compared to Earth, but to have such big features on it is crazy.
Yeah, it's got some amazing geography and amazing geology as well. So no wonder scientists are so interested in it.
Absolutely. All right, so question 3. What's the hottest planet in our solar system? Well, the closest planet to the sun is Mercury. And so you might think that that would be the hottest planet. But actually, Venus, which is the second planet away from the sun, is still pretty close to the sun. But because it has such a dense atmosphere, it has what essentially a massive greenhouse effect, just like is causing global heating here, but much stronger in Venus. And the surface can get so hot that lead, which is a solid metal on Earth, would just melt to liquid. It gets to about 470 degrees Celsius, which is not comfortable. Mercury itself, you might think it'd be hotter, but it has a very thin atmosphere, and so it doesn't really keep heat very well. And also, it rotates really slowly. So when it's nighttime on the dark side of Mercury, actually it gets really cold. It gets to like minus 180 degrees. So it heats up quite a lot, and it does get very hot in the daytime, but not quite as hot as Venus.
Yeah, Venus is incredible. Venus was the first planet I ever saw through an amateur telescope, and it's
wow.
You don't see very much, but it was amazing. It was
because it's really bright, isn't it?
Yeah. Right, let's have our picture round. So we had meteorite or meteor wrong. Now, we had 3 images and only one of them was a meteorite. So well done if you guessed that the first image was a meteorite. This is, in fact, a lunar meteorite. So it's a piece of the moon that's been blasted off the surface and eventually landed on Earth. And they are very rare finds, but they do happen. Sometimes when an asteroid strikes the moon, it will knock a piece off and eventually it can find its way to Earth. And this one was actually found in Northwest Africa, and we have this in the museum. Our second image was a meteor wrong. This one is in fact a coprolite. So it's fossilized poo.
Ah, so classy.
Absolutely.
Audience at home, just be grateful for the really refined and cultured entertainment that you're getting here from the Natural History Museum.
Fossilized. Wait. It is fossilized poo, though, from an extinct ground sloth called Mylodon darwinii, which was named by Richard Owen in honor of Darwin, who found the first Mylodon specimen. So this is 13,000-year-old poop found in Chile, associated with a specimen that Darwin found. So that's
I guess, like if you're going to find poo, want it to be really cool fossilized poo, not just recent.
Absolutely. And then finally, our third very interesting looking image there. It wasn't a meteorite, but it is associated with meteorites. It's a tektite. So they're made of earthy materials. They're actually formed of glass, and they're what's formed when a meteorite actually impacts the Earth. It's the ejector material. So they do come in all kinds of weird sort of shapes and sizes, and we've got a few in our collections at the museum.
So that was actually kind of a tricksy question, Alison, because
it was a little bit
right adjacent. I'm not quite right.
Yeah, a little bit sneaky.
I respect that. Question 5. So, like I was saying, so far only 2 human-made spacecraft have gone out of the solar system, and these are Voyager 1 and Voyager 2. Imaginative names, I know, 1 and 2, but Voyager because they were always meant to travel long distances. And they were launched in the 70s. And there are some other probes, like Pioneer 10 and 11, that were launched before the Voyager probes. Voyager 1 in particular has really picked up the pace and has overtaken all the other probes. And back in 2012, it entered officially into interstellar space. Voyager 2, a little bit behind, left our solar system in 2018. Both are still active and are still sending in, scientific information about their surroundings back to Earth, but those signals take longer and longer to reach Earth the further they get away. So we'll see what we can learn.
It's amazing. I just love the idea that there'll be something out there deep into the interstellar space long after we're.
Yeah, and once you're out there, just how far it must be from anything.
Yeah.
That's amazing.
Now, question 6 was a particularly tricky one, I think. So we asked you, what was syzygy? So let's have our answer. So it's when 3 celestial bodies line up in a row. So as objects like planets and stars move through space, sometimes they happen to line up. Is a solar eclipse, where the sun, the moon, and the earth are all lined up, so the moon blocks our view of the sun. So it is a tricky one. I didn't know this one. I had to look this one up. But well done if you got this one correct.
And now you can all win at Scrabble.
Yes.
When you get that hand and it's just all wise, you know what to do.
Yeah.
Okay, going into the science fiction round. What TV show did Mae Jemison feature in when she came back from space? And the answer was Star Trek: The Next Generation. But if you put any Star Trek show, we'll give you a point. So she was particularly inspired by the character Lieutenant Uhura from the original series of Star Trek, who was played by an actor called Nichelle Nichols. And Jameson would even start her transmissions from the space shuttle with Uhura's classic line, "Hailing frequencies open." And Nichelle Nichols herself, the actor, she wasn't just an actor. She was a real activist and an advocate for particularly Black Americans to take up careers in space. She was really kind of influential in trying to kind of diversify the early efforts to get into space. So I think it's really interesting that Nichelle Nichols went from acting in Star Trek to advocating for involvement in the space industry, and Mae Jemison went from being actively involved in the space industry to acting in Star Trek.
I'm going to out myself. I am a Trekkie. I love the first series of Star Trek and Star Trek Next Generation as well.
So have you seen the episode of Mae Jemison?
I don't know if I have. I probably have.
Now that you've seen her face, you might have to go back and rewatch.
Yeah, I might have to go back and rewatch. Yeah. Right. Question 2 in our sci-fi round was, what is a parsec? Hopefully many of you guessed this one. So it's actually a unit of length. It's used to measure the distances to astronomical objects outside of the solar system. So some tricky numbers here. 1 parsec is approximately equal to 31 trillion kilometers, 10 trillion miles, which is incredible. It equates to about 3.3 light years, apparently, if that means anything to anyone.
Oh yeah, my reference for everything is light years. So the corner shop is like 0.0000000000001 light years.
So
in Star Wars, the original implication was that it was a unit of time, right? Because they said
yes.
The Kessel Run in under 9 parsecs or something.
Yeah.
Naughty George Lucas.
Naughty. Didn't do his homework.
All right, now to the round you've all been waiting for.
Yes.
So let's pull up that first image. I hope that we managed to convey the majesty of this film. So let's see. It was, of course, the chestburster scene from the original Alien film, which, in my opinion, is one of the best sci-fi films ever made. I love parasites. I'm a biologist. I'm an immunoparasitologist by training, and just that life cycle of that alien, and the fact that you never see it until like quite late in the film. It's always held a space in my heart. And
yeah.
I didn't get any of the hands right. Like none of them have fingers, none of them have noses. But I managed to get the headband, so that's the important part.
I think it's brilliant.
Thank you, MS Paint.
Yeah. Aha. So our second picture. How many of you guessed the film?
So I know the answers to this, but when I first saw it, it was a bit of a deep cut because of all the scenes from this film, I wouldn't have. It's not the scene that I remember the most. The scene I remember the most is I don't want to say it without by ruining the answer, but it's when Will punches an alien in the face. One of the most memorable scenes from obviously Independence Day, drawn by Helena.
Yeah,
Big-
that alien punching in the face would have been a tricky scene to draw.
Yeah, you'd have to get all the speed lines and stuff.
Yeah.
But yeah, the end bit where they're walking away from the burning mothership, but it's a pretty iconic scene as well.
Yeah, yeah. And very nicely drawn by Helena.
Oh, beautiful. She's really got the color of those jumpsuits right.
Yeah. Oh,
okay.
wow.
This one's a slightly deeper cut. For any sci-fi fans out there, I hope you got this. So
Yeah.
that's what it is, Alison.
It's slightly obscure, but it is The War of the Worlds, but the 1953 version, the best version of this.
So people might be a bit more familiar with War of the Worlds as having alien tripods rather than flying spaceships, because in the book tripods and in some of the later tripods.
Yeah, so this is the 1953 film obviously resets the drama to America in the 50s. And yes, they're not tripods, they are these sort of flying saucer things, but with laser.
And they've got those kind of big green glowing parts.
Yes, yeah.
You've really captured the majesty of the green glow there.
It's beautiful. And that house is meant to look all dilapidated because it was I meant to draw it like that.
Okay, let's go on to number 4, I believe. So, some of the text in this might have given it away, and the towel. But again, the text is not super easy to read. Microsoft Paint is not the kindest to letters. But I hope some of you got it at home. We've got Arthur, we've got Ford, and we've got Marvin. What is it?
Of course.
So there was the 1981 TV show and the 2005 film, both excellent.
Yeah.
So that was by Sarah, and I really loved the just pure grump on Marvin's face.
She's really captured that.
That is one paranoid android. So was the last one?
Oh, this one. Yeah.
I'm sure you've managed to deduce that this was by Sarah. A slightly deeper cut for the sci-fi heads out there. This is from Firefly. We'll also accept Serenity, the film spin-off. Don't worry, I cleared that with Sarah. She is okay with Serenity.
Yeah, I had to think about this when I first saw it, but I did guess it.
I mean, Firefly is a weird one because it's so beloved by fans, but it got cancelled quite early, and it didn't really get the commercial love that it deserved. That's why later they managed to make a spin-off film, Serenity. But there's still people asking to bring it back. It's kind of like a Western in space.
I really enjoyed it.
And so by extension, I'm sure you guys can guess that by Sarah. No one else draws that well out of us.
I can't believe she did that in.
So this again is for the heads. This, in my opinion, this is the best Star Trek film. It is, of course, Galaxy Quest. It's a kind of parody sci-fi film about a cast of actors who are in a kind of Star Trek style TV show, and they meet what they think are some super fans, but they turn out to be aliens who have been watching Galaxy Quest, the TV show, and assume that it's a documentary and need these mighty heroes to come and save their civilization. Absolutely amazing. Definitely watch it.
It's so good. And yeah, this is inspiring me to make me watch it again because I haven't seen it in a long time.
Absolutely.
So that was the last question, wasn't it? So that's the end So we had a total, I think, of 26 points possible. So let us know how you did, guys. Pop your
team names and scores.
names and scores in the chat and let us know how you did. Hopefully we've got some high scorers. Hopefully it wasn't too difficult a quiz, but we'll see.
Also, I hope it wasn't too easy. I don't want everyone getting 26.
Absolutely. We can't make it too easy.
Down the middle.
Do a bit of work. Team name Lava Tubes. Love it.
Ain't no tube like a lava tube.
Intergalactic penguins. The best kind of penguins.
Deep Space Wine. Such an amazing space station, that.
Oh yeah, that's my favorite.
Team Thor's Hammer. Nice. I'm really liking all the Spot quiz. I'm loving all the puns and references here. Thank you so much, guys. I hope you guys have enjoyed the quiz as much as we enjoyed putting it together and hosting it.
I've absolutely loved it. It's been brilliant. The discussion, the panel discussion was amazing, Khalil. Sarah, and Helena are fantastic. I'm loving the spacey background as well. That's really that's really
Yeah, just lets us feel like we're in situ. But yeah, we're so lucky that we get to have all these amazing conversations every week with like all sorts of scientists. One week we'll be talking about killer whales, then it'll be coral, then it'll be beetles, and now it's space. Yeah, this is truly.
We have the best job. We had some scores there. Oh, someone got all the pictures and the drawings right.
Nice one.
So we had 14. I think somebody got 9. From I think it was Daniel, age 9. Well done, guys. It was a tricky quiz.
19. Team Bring Laika home. Oh, that's one animal that definitely ain't coming back.
No. The astronauts got 9. Well done, astronauts. 21. Wow.
Okay, I think we've got 21 to beat.
Oh, yeah, that's really good.
So it looks like Team Spot Quiz with 21 be our winners tonight. Well done, all of you at home. Thank you so much for joining us. This has been Lates from the Natural History Museum. This has been Alison. I've been Khalil. And this happens on the last Friday of every single month with a different theme each time. So do check in on our website to see what our next one's going to be. And remember, our Nature Live online shows are twice a week on Tuesdays and Fridays. We've got some really good ones lined up. We've got volcanoes, we've got jellyfish, we've got some really, really great ones. So thank you so much for joining us. Thank you, Alison, for helping me produce and run this quiz. And I've had an amazing time. Good night, everyone, and I'll see you next time.
It's been brilliant. See you guys.
Thank you.